Let's work more with cumulative area so far functions. Let's think back to when we had a constant little f function, and we took the cumulative change so far function. What did we see there? We had a constant little f, and then what was big F? It looked like that, right? So what's a quick way to describe that function? I think linear is an interesting way to say it. What if I started with cosine x? What do you think we would get for our cumulative area so far function? So we'll start with cosine x, like that. So go ahead and stop the video, trace out cosine, and then do the boxes being taller and not so tall thing, and see what you get. All right, welcome back. So I'd say our first box is pretty tall, so my function is going to increase pretty quickly. And then our next box is almost as tall, so the function is going to still increase pretty quickly, but not quite as quickly. And then by the time I get over here, my boxes are not as tall, so this is going to be increasing less quickly. And by the time I get here, the boxes are pretty short and even zero height. So my antiderivative, I guess I should be drawing this differently, but my cumulative area so far is going to be here just flat, and then here I'm going to be adding a negative box, and then another negative box, so a negative height, positive width, and so this is going to be decreasing. And by the time I get here, my boxes are going to be fairly tall, have a fairly large negative area. So this is going to be, in little steps, decreasing quite quickly. And then by the time I get over here, the boxes are still negative height, but not as negative. So this will still be going in steps farther down, but not as quickly. And by the time I get here, my box height is 0, so my next step would be the same height, same y value, and then I'm adding more positive boxes, but they aren't very big to begin with. So this cumulative area so far function will be increasing, like that. What are we getting there? Well, before we decide for sure, let's think about starting here. So notice we said starting at 0. Let's start going backwards from 0. My box here would have a fairly large positive height, but negative width, and so that would be subtracting from the cumulative area so far. So it would go down like that. And then the next box would still have a fairly large height, but not as large, but a negative width. So it wouldn't be exactly in line, it would be kind of not quite as strongly sloped. So I think at this point we've kind of convinced ourselves that our big F function is sine of x when our original was cosine of x, that we took the cumulative area so far. So now what do you think will happen if we use sine of x and take the cumulative area so far for that? So sketch it out for yourself, and we'll go try it in Desmos. All right, before we get to using sine here as our original function, I wanted to just quickly confirm the sketch we did by hand using cosine as our original function. So here we're adding fairly large boxes. Actually, maybe I'll set the box size down a bit here. Fairly large boxes, so our cumulative area so far function, this purple curve, is increasing fairly quickly. But by the time I get over here, the boxes aren't so tall, so the purple curve is still increasing, but not as quickly. And now that I'm over here, my boxes have negative height, but positive width. So my total area so far is now decreasing. That's like throwing the car into reverse gear. I now have kind of a negative velocity, you could say. And so my total distance so far measured relative to my start point is getting smaller. And then here, the boxes have a fairly large negative height, and so my cumulative area so far curve is decreasing fairly quickly. And then by the time I get over here, the boxes have a not so large negative height, so my cumulative area so far curve is decreasing less quickly. And now I'm back into positive territory. I'm out of reverse gear, back into forward gears. And so my cumulative area so far curve is increasing again. And if I go back over here, again, these boxes have positive height but negative width. So my cumulative area so far curve is decreasing as I move to the left. And again, we're seeing that cumulative area so far curve basically looks like sine. So now let's try, we'll bring this back to 0. And we'll put a sine in here. And what do you think we'll end up getting as we're increasing, as we're moving our endpoint farther and farther, we're adding taller and taller boxes. They started out not very tall, so my purple curve, cumulative area so far, started out not increasing very quickly. But now they're taller, so my cumulative area so far curve is increasing more quickly. And by the time I get here, the boxes are pretty tall, so cumulative area so far is increasing quite quickly. By the time I get over here, my boxes are now basically 0 height, so this is not increasing much at all anymore. And now I have negative height boxes, so total area so far is decreasing. And then let's do this going backwards. This is kind of fun. My boxes have negative height, and I'm going backwards, so they have negative width. So the cumulative area so far curve is decreasing as I move backwards. Sorry, increasing as I move backwards, because these have an overall positive area because they're negative height and negative width. So what curve are we getting there? You might have thought if I'm doing cumulative area so far curve on sine, I'll get cosine. And did we get cosine? Well, cosine starts starts high and starts moving down. This function starts at 0 and immediately starts moving up. So that's kind of like the opposite of cosine. Is that a negative cosine? Well, kind of, but negative cosine would start at -1 and top out at 1, rather than starting at 0 and topping out at 2. So overall, it seems like we got negative cosine, but shifted up by 1, which seems like it might be a mystery. Like, it kind of makes sense based on the graph, but based on the formulas, we're not really sure. So let's go back to paper and pencil. So we might have thought that big F would be cosine, or maybe negative cosine. What was it actually? It seemed like it was negative cosine x plus 1. It had a vertical shift to it, which is kind of interesting. So we played with linear, with a constant rate here, and we took the cumulative change so far. We played with some trig. We played in a different video with a linear change rate, and then we got something curved up in one case, something curved down in the other case. Anything else that would be good to try? Well, you might think that e to the x is a natural thing to try after sine and cosine, and that's not bad. We could draw it here. It ends up actually being slightly confusing for a diagram, so I'll let you play with it if you want to, but you don't have to. What other functions are there? Log x. It turns out log x, that cumulative area so far ends up being very hard to interpret. So we'll say it's hard to interpret. And that is actually something that we would do in Calc 2, so you can leave that alone. I just happen to have some other curves sketched out here that would be good to try. And this is a worksheet that's in the giant file of all homework. It's called the Chapter 5.4 worksheet. I encourage you to go print it out and sketch the cumulative area so far curve for this. Now this is starting at a equals -4. This one I'm saying start at a equals 0, and then this one start at a equals 1. and I'll do kind of an answer key in the next video.